Welcome. Let's look at one example where we can use an exponential growth function. Here we have a scenario where the world population in the year 2000 was approximately of 6.08 billion, and we also have information that the annual rate of increase was about 1.26%. Now we can conclude that this is an exponential growth function because the population was increasing. We have to exponentially increase. The first thing that we want to do, we want to write down a function that will model the world population. Any exponential function will have the following form. Y equals the starting value times the rate of increase or decrease, but in this case, we have an increase, all raised to the x. So now let's see if we can find this information. Here we can say that the year 2000, it is the year zero of our observation. So if this is when we can start observing the population, then we can say that the starting value was approximately 6.08 billion. So let's plug that in our equation. We're going to have y equals 6.08. All we need to do now is try to figure out what was the rate that we were increasing by. And we have that information here. The annual rate of increase was about 1.26%. But we are not going to plug in 1.26 in here. That is wrong. The first thing that we have to do is convert the percentage into decimals. Because notice that this information is given to us in percentage. One way to do that is get the percentage and divide it by 100. Now we have a value of 0.0126. And we're not just going to plug in this value as our rate of increase. That is still wrong. What we will do, we're going to add this value to 1. And that is going to give us 1.0126. Now this is the rate of increase that we will use. And now we have an equation that we can use that will model the world population with the information that we are given. So I'm going to do a little side note on this. The reason why we need to add the decimal representation of our percentage is because if our rate is just 1, we're neither increasing or decreasing. But for us to increase, we need to have a base that is greater than 1. So all we have to do, we just have to add the percentage of increasing to the value of 1, and that is going to give us the base that we can use to represent the rate of increase. And now that we have an equation, now we can answer part B. Now let's let x be the number of years past the year of 2000. What we would like to do, we would like to find the population in the year of 2010. So if our observations started at the year of 2000, then at the year of 2010, 10 years have passed. That is the value that we can assign to the variable of x. If we let x be equals to 10, then we are saying we are looking at 10 years after the year of 2000, which is what this question is asking us to think. So now let's get this value of x equals 10, and let's plug it in into our function. And now this is something that we can plug in our calculator. Now to access the exponential button, we will find it here underneath the clear button. Now let's plug in 10. So we have our conclusion, 6.89 billions. Because remember that the given information was given to us in billions as well. Now let's visualize this result. Here we had an exponential growth function where at the year of t equals 0, we had a starting population of 6.08 billion. And when we saw this population 10 years after, our population was 6.89. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.